Descriptive statistics include various measurements that help summarize and interpret data. Key measurements include central tendency, dispersion, skewness, kurtosis, and other elements that provide insights into the characteristics and patterns within the data. Here's an overview of each. Measures of central tendency. These are statistical values that represent the center or average of a dataset. The most common measures include the mean, average, median, middle value, and mode, most frequent value. Each measure provides a different perspective. The mean is sensitive to all values in the dataset, the median gives a middle point that is not affected by outliers, and the mode identifies the most common occurrence. Measures of central tendency help researchers understand what a typical value in the data might be, providing a baseline for comparison. Measures of dispersion. Dispersion measurements show how spread out or varied the data points are around the central value. Key measures include the range, difference between the highest and lowest values, variance, the average of square deviations from the mean, and standard deviation, the square root of variance, indicating average deviation from the mean. These measures highlight the variability within a dataset, helping to distinguish between consistent and diverse data. For instance, a low standard deviation indicates that data points are close to the mean, while a high standard deviation signifies greater diversity in values. Skewness. Skewness measures the asymmetry or lean of data distribution. When data is symmetrical, the skewness is close to zero. Positive skew indicates a longer or fatter tail on the right side, higher values, meaning data is clustered toward the lower end. Negative skew indicates the opposite, with data skewed toward higher values. Understanding skewness is essential because it helps identify biases or outliers that might affect the interpretation of central tendency measures, making it useful in assessing distributions that deviate from normal. Kurtosis. Kurtosis measures the tailedness or peakedness of the data distribution. A high kurtosis value indicates a distribution with heavy tails and a sharp peak, suggesting many outliers. Low kurtosis implies lighter tails and a flatter peak, indicating that data points are more evenly distributed. Normal distributions have a kurtosis around 0. Understanding kurtosis is important for assessing the probability of extreme values, which can impact statistical tests that assume a normal distribution. Other descriptive measures. Additional measures include frequency distributions and percentiles, which help describe the position of data within the dataset. Frequency distributions count how often each value or range of values appears, making patterns easy to identify. Percentiles, such as the median, 50th percentile, provide insights into the data's spread by showing relative positioning. These measures allow for more in-depth analysis of the data, helping to draw meaningful conclusions from specific data subsets or trends across ranges. Together, these measurements under descriptive statistics give a comprehensive view of a dataset, allowing researchers and decision-makers to interpret data accurately and make evidence-based decisions. Importance of each, advantage and disadvantage, and application in MEA. Each component of descriptive statistics, central tendency, dispersion, skewness, kurtosis, and additional descriptive measures, holds unique importance in data analysis. When applied in fields like Master in Educational Management, MEM, they provide crucial insights into student performance, school climate, and teacher effectiveness, supporting data-informed decision-making and planning. Measures of central tendency are essential as they provide a single representative value summarizing a dataset. Their advantage is that they simplify complex data into understandable averages, like mean, median, and mode, making it easier to spot trends. However, they may not capture data variability, which is a disadvantage when assessing inconsistent data. In MEM, central tendency can show average student grades or attendance rates, helping to set performance benchmarks and inform curriculum decisions. Measures of dispersion are valuable because they describe the spread of data, offering context to averages and revealing how consistent or varied data points are. This is advantageous for identifying outliers or understanding the range of performance within a dataset. However, it can be complex to interpret without additional statistical background. In MEM, dispersion can help analyze test scores across schools or identify which classes have wide variability in student performance, aiding targeted interventions. Skewness is important because it shows whether data is symmetrically distributed or biased towards higher or lower values, impacting how central tendencies should be interpreted. A major advantage is that it highlights data asymmetries, but a disadvantage is its reliance on more advanced interpretation. In MEM, analyzing skewness of student scores may reveal whether most students score above or below the average, which can guide adjustments in teaching strategies or assessment standards. Kurtosis indicates the peakness or tail heaviness of a distribution, highlighting the potential for outliers. This is advantageous when assessing the likelihood of extreme scores, such as very high or low student performance, but can be challenging to interpret without an understanding of distribution shapes. In MEM, Kurtosis can help in assessing program success by highlighting which programs may have extreme results or high-impact changes, supporting resource allocation decisions. Other descriptive measures, like frequency distributions and percentiles, offer flexibility by presenting data in detailed distributions and showing the relative standing of data points. This provides a broader perspective but requires extensive data management. In MEM, these measures can be used to analyze school climate surveys, showing, for example, the distribution of satisfaction scores among students and teachers. This informs leaders about prevailing sentiments, helping to improve policies and practices. Altogether, each measure enhances the quality of data interpretation in MEM. By understanding central tendencies, spread, and patterns, school leaders can make data-informed decisions, such as improving student engagement, addressing gaps in teacher performance, and fostering a positive school environment. These descriptive statistics offer the precision needed for meaningful insights, though they require careful analysis to avoid misinterpretation.